Okay. Yeah, anyone can say what I thought or what I discussed yesterday? Anyone quickly? What are the at least topics you can tell? What topics I have discussed? Hemanta. Hemanta? Hello. Microphone under repair. Sir, do the response to microphone is under repair. Yes, what about others? Hemant microphone is under repair. Other students are there, na? Can respond. Hello. So, Mother Sanam. Before I start, let me speak. What about Kritika? Kritika Sharma.
Yes, sir. Good
Hello.
morning, sir. Hello. Hello. Hello.
Yes, ma'am. Nishchit Radhe. Kritika, yes, sir. Can you just?
Yes, sir.
Yeah. Tell me what topics. Yeah, I'm audible. It is audible.
Okay. Okay, sir.
Yeah, it is audible. You can speak. Kritika.
I didn't hear your question, sir.
Hello. Yeah. You didn't hear my question. Now it is my voice is audible.
Yes, sir.
I am asking you just can you name the topics what I have discussed yesterday? Yeah.
Mm, yesterday.
Yeah. So much time you need to think what I discussed yesterday.
Mm, so,
Hmm. Unable to recall.
yes, sir.
Okay. Manu. Manu. Maniratna. Hello. Harshita also joined. Harshita NB.
Yes, sir.
Harshita NB. Can you tell me what topics I discussed yesterday?
Sir, yesterday, second class, I didn't attend, sir.
It is first class you can tell now. First hour I took. So what topics I discussed in the first hour? So finding it so difficult to just name the topics. I'm not asking you to explain the concept, just topics name. What are Shita? Vivek. Hello. ವಿವೇಕ್ ಮಾತಾಡ್ಬೇಕು. ವಾಟ್ ಹರ್ಷಿತಾ ಏನು ರೀಕಾಲ್ ಮಾಡಲಿಲ್ವಾ? ಆಗ್ಲಿಲ್ವಾ? ಗೊತ್ತಾಗ್ಲಿಲ್ವಾ ಏನ್ ಟಾಪಿಕ್ ಮಾಡಿದ್ದು? See, I discussed about RLC layer and MAC layer. Okay, that is I said in LTE the layer 2 is subdivided into 3 sub layers. Okay, one is PDCP, second one is RLC, and third one is the MAC. So yesterday I discussed about the services and functions of RLC and as well as the MAC layer. Okay, and I also discussed the PDU formats of RLC and as well as MAC. Okay, just to have a recap, let me just things. Okay, so I said RLC layer performs segmentation and concatenation. Okay, on the PDCP PDUs. Okay, based on the size indicated by the MAC, right? And it also reorders the RLC PDUs. Okay, and it supports an ARQ mechanism. Okay. In brief, these are the 3 key things what I would like to tell about the RLC. And about MAC, channels onto the transport channels, and it also does the scheduling. Okay, so this is all about just in brief about MAC layer, right? So and priority handling, then it will do the multiplexing, because as I said, there will be only one MAC entity in the user equipment and as well as in the ENB, right? And it also does hybrid ARQ operation. Okay, and these are the different data transfer modes performed in the RLC. So 3 are there. One is the transfer mode, the transparent mode. Second one is unacknowledged mode, and third one is the acknowledged mode. Okay, so these are the 3 different types of data transfer modes supported by the RLC. Okay, so as I said, among these, unacknowledged mode is used for delay sensitive and error tolerant applications like voice over IP. Okay, voice over internet protocol. So in brief, what I'm telling. Then yeah, I discussed about the RLC PDU formats. Okay, RLC PDU formats and as well as the MAC PDU formats. I hope so. This is about the RLC PDU format, right? So I said, depending upon those 3 data transfer modes, we have these PDUs. EMD PDU, that is for transparent mode data PDU, right? Unacknowledged mode data PDU, then acknowledged mode data PDU, then EMD PDU segment. So these are the different fields of this RLC PDU. Okay, I told what is FI, E, sequence number, then D bar C, RF, P, and other things, right? What is LSF, SO? So just have a look about that, what is the function of each and every bit in the RLC PDU format. And similarly, I discussed about this MAC PDU, right? I said MAC PDU consists of MAC header and the MAC payload. So this MAC payload will have MAC control elements, a number of MAC control elements, and as well as MAC SDUs and additional padding. This MAC header will have MAC subheaders, right? So I told about these things. And this is a MAC subheader format. It has totally 5 fields. One is R, extension field, logical channel identifier, right? F field and L field, right? I said what is F field and what is L field also. So F field is the format, field indicates size of the length field, right? And L field is the length field indicates the length of the corresponding MAC video. Okay, so I think I have discussed about all these things yesterday. So let me start with the ARQ procedures. Okay. I hope many are there. So 27 people are there. Okay, so you're all with me because when I ask you questions, you're unable to tell the topics. Aishwarya Rao. Sania. Sania is there? Hello? Okay. Fine. So this ARQ means automatic repeat requests, right? This is done at the RLC layer, radio link control layer, right? So LTE uses a dynamic and efficient two-layer retransmission scheme. Okay, I repeat once again. As I said, this ARQ means what? Automatic repeat request procedure. So LTE uses a dynamic and efficient two-layer retransmission scheme. Okay. So what is a two-layer retransmission scheme? One is the fast hybrid ARQ. Okay. Protocol. So this protocol have low latency and low overhead feedback. As I said, hybrid ARQ is done in the MAC layer, right? This is one layer, what I feel. So a fast hybrid ARQ protocol with low latency and low overhead feedback in the MAC layer. That is one thing. Another one is a highly reliable selective repeat ARQ protocol, which is carried out in the RLC layer. That's why we say two-layer retransmission scheme. Okay? One at the RLC that we call ARQ, one at the hybrid ARQ that is at the MAC layer. Okay? So this hybrid ARQ protocol is responsible for handling transmission errors. Okay, those transmission errors happens while performing retransmission, right, based on the hybrid ARQ process. Okay, either with the incremental redundancy or with the chase combining. Okay, so that will be handled by the physical layer. This chase combining and all those things we have discussed in module 3. What I feel. Okay. See, this ARQ protocol in the RLC layer is used to correct the residual hybrid ARQ errors. Okay? This residual hybrid ARQ errors occurs due to the error in this hybrid ARQ acknowledgement feedback. Okay, so to correct those errors, the ARQ protocol will be used in the RLC layer. Okay? So this ARQ procedure so only perform in the AM transfer mode. Yeah, as I said, RLC supports 3 different types of data transfer mode, right? One is TM, second one is UM, third one is AM. Okay, out of those 3, only in the AM transfer mode, this ARQ procedure is performed by the AM RLC entity. Okay, the latency associated with this is a little bit higher compared to the latency with the hybrid ARQ, which is done in MAC layer. Okay. Right. So the reliability of the hybrid ARQ protocol is determined by the error rate of the feedback. How reliable the protocol is. Okay. So that will be determined by the error rate of the feedback. And it is a little bit costly to achieve that reliability. Okay. Because of this hybrid ARQ, acknowledgement feedback. So in LTE, they have adopted the second layer ARQ protocol, which is in RLC layer, right? So which is to correct the error event due to hybrid ARQ feedback errors. Okay. So this additional ARQ protocol, which is there in RLC layer, provides much more reliable feedback protected by the CRC. Okay. So this design means the two-layer retransmission scheme, right? One net I said ARQ in the RLC and hybrid ARQ in the MAC yields low latency and low overhead without sacrificing the reliability. So that is the advantage of this two-layer retransmission scheme in the LTE. Okay. So most of the errors are captured and corrected with the low overhead hybrid ARQ protocol in the MAC layer. Okay. So here there will be not much resource demand in the ARQ retransmission. Okay. So ARQ retransmission is triggered by an ARQ negative acknowledgement received at the transmit side of an AM RLC entity. So when do we trigger this ARQ retransmission? When the hybrid ARQ retransmission will be triggered, that we would like to know, right? So this ARQ retransmission is triggered by an what? ARQ negative acknowledgement received at the transmit side of the AM RLC entity. Because I said only this AM mode is used for this ARQ, right? Yeah. So the ARQ negative acknowledgement is received either by the status PDU from its peer AM RLC entity or by the hybrid ARQ delivery failure notification from the transmit MAC entity. So because of these two, it is possible to receive the ARQ negative. Okay. So I said the ARQ negative acknowledgement will be received either due to what status PDU from its peer AM RLC entity or by the hybrid ARQ delivery failure notification from the transmit MAC entity. Right. So this happens when the maximum number of hybrid ARQ transmission is exhausted without a successful transmission of the transport block. Okay. So during that time, the ARQ negative acknowledgement will be received by the AM RLC entity. Right. So during that time, the ARQ retransmission will be triggered. So the status reporting is triggered by setting the polling field of the RLC data PDU to 1. So I think I discussed, as I said, about the RLC data PDU. No? In that, this status reporting will be triggered when by setting this polling field to 1. And the negative acknowledgement reporting is contained in the status PDU. So I hope you understand the link, right? This negative acknowledgement reporting will be there in the status PDU. That status will be, status reporting will be triggered when that is triggered by setting the polling field of the RLC data PDU to 1. So that is all about the ARQ negative acknowledgement restriction. So an hybrid ARQ delivery failure, I think there is a second chance. I said the ARQ negative acknowledgement is due to two things, right? One is about status PDU, another one is about the delivery failure of hybrid ARQ notification, right? So in that case, what happens? This hybrid ARQ delivery failure is notified by the what? MAC entity, right? So when the MAC PDU is not delivered successfully after the maximum number of hybrid ARQ retransmissions. So that is the case. Fine. So upon receiving this hybrid ARQ negative acknowledgement, right, the transmit side of an AM RLC entity will deliver the AMD PDU. Okay. What I said, after receiving this hybrid, after receiving an ARQ negative acknowledgement, right, the transmit side of an AM RLC entity will deliver the AMD PDU. Okay. So if that is fits within the total size of the RLC PDO indicated by the lower layer. So lower layer is what? MAC layer, right? Otherwise, it segments, means it will do the segmentation, then that AMD PDO, and form the new PDU segment that fits the PDU size. So that is what this segmentation is. Okay. So if the maximum number of ARQ retransmissions is reached, then the AM RLC entity will notify the upper layers. Means AM RLC entity that is there in RLC layer, right? That will intimate to the PDCP layer, which is the upper layer for RLC. Okay. So that is about that. Then hybrid ARQ protocol of the MAC layer and the ARQ of the RLC layer. Okay, both will be terminated at the ENB. But this is slightly different in case of other network, that is in case of HSP and other things. So this, because hybrid ARQ protocol of the MAC layer and as well as the ARQ of the RLC layer, both are terminated in the ENB, that enables the tighter interaction between this hybrid ARQ protocol and as well as the ARQ protocol. Okay, so benefits of this architecture is, one is we say fast handling of the residual hybrid ARQ errors, and second thing is it is possible to have variable ARQ transmission size. Okay. So this is all about the ARQ procedure, what I would like to say. So what is the takeaway of this topic, ARQ procedure? Quickly, is it possible to say? As I said, LTE uses a dynamic and efficient two-layer retransmission scheme. What is a two-layer transmission scheme? What I said, fast hybrid ARQ protocol with low latency and low overhead feedback in the MAC layer, right? And this highly reliable selective repeat ARQ protocol is used in the RLC layer. So means one retransmission technique is used in the RLC layer, another one is used in the MAC layer. So at a two-layer, that is why we say it is a two-layer retransmission scheme, right? So this hybrid ARQ protocol is responsible for what I said. It is responsible for handling the transmission errors. Okay, by performing the retransmission based on the hybrid ARQ process with either incremental redundancy or with the change combining. Okay, so which is handled by the physical layer. And I said that this ARQ protocol, that ARQ protocol in the RLC layer is used to correct the residual hybrid ARQ errors. Okay, this hybrid ARQ errors occurs due to the error in the hybrid ARQ acknowledgement feedback. Okay, so I said this ARQ procedure is performed only in the AM transfer mode by the AM RLC entity, and the latency associated with this RLC layer ARQ is much larger than the latency associated with the hybrid ARQ protocol, which is done in the MAC layer. And so I talked about the reliability. So the reliability of the hybrid ARQ protocol is determined by what? The error rate of the feedback. So achieving this reliability is a costly affair in case of hybrid ARQ acknowledgement feedback. That is why the LTE adopts a solution which uses this second layer ARQ protocol. Right? So that is used to correct the error event due to hybrid ARQ feedback errors. So this additional ARQ protocol in the RLC layer makes the system much more reliable, feedback protected by the CRC. Okay, that yields low latency and low overhead without sacrificing the reliability. So this is what all about the procedure. I said that the errors are captured and corrected with the low overhead hybrid ARQ protocol. Right? So when this ARQ retransmission will be triggered, that is triggered by the ARQ negative acknowledgement received at the transmit side of the AM RLC entity. Okay. So this ARQ sorry. ARQ negative acknowledgement is received in two ways. Okay, one is what? Status PDU from its peer AM RLC entity, or by what? Hybrid ARQ delivery failure notification from the transmit MAC entity. Okay, so this happens when the maximum number of hybrid ARQ transmission is exhausted without a successful transmission of the transport blocks. Okay. So this negative acknowledgement reporting is contained in the status PDU. That status reporting will be triggered by setting the polling field of the RLC data PDU to 1. So that is the first way. For the second way, that is a hybrid ARQ delivery failure. As I said, it is notified by the MAC entity, right? So that happens when the MAC PDU is not delivered successfully after the maximum number of hybrid ARQ transmission. Okay. So after receiving this ARQ negative acknowledgement, I said the transmit side of an AM RLC entity will deliver the AMD PDU. Okay. If its size fits with the total size of the RLC PDU indicated by the lower layer. Otherwise, it will do the segmentation, okay, of this AMD PDU, and it will form the new PDU segment which will fit the PDU size. Okay. So if the maximum number of ARQ retransmissions is reached, then the AM RLC entity will notify the upper layers. Okay. So this hybrid ARQ protocol of the MAC layer and the ARQ of the RLC layer both are terminated at the ENB. Okay. So this enables the tighter interaction between hybrid ARQ protocol and the ARQ protocol in LTE. So benefit of this structure or architecture, what I can say is it is possible to handle. There is a fast handling of the residual hybrid ARQ errors, and it is possible to have variable ARQ transmission size. Okay, it is possible to have a variable ARQ transmission size. So this is all about the ARQ procedure, I said. So let me take the next topic as the RRC overview. So far I discussed in this module is what about PDCP, RLC and MAC. So these are the three sub layers of the L2 layer in the LTE. Okay. So any questions to be asked, we can ask. I will give 5 minutes for this to ask the questions. Otherwise, I will start the next topic, that is RRC. So any questions? Neha? Yes, Neha. No questions to ask?
No.
Yeah, no questions? No questions. Understood ARQ procedure? What I thought. No doubts. So module 5 is very simpler than I think module 4. So as I said here, this LTE protocol stack is divided into two parts. One is the user plane and second one is the control plane. Okay, the user plane provides, or user plane is responsible for transporting the IP packet carrying the application specific data from the PDN gateway to the user equipment. Okay, how does it carries that IP packet from PDN gateway to the user equipment is the question, right? So it does by doing the segmentation, concatenation, by using the EPC, that is Evolved Packet Core protocols, and as well as the GPRS, tunneling protocols, we say GTP. Okay, and from ENB, okay, from ENB to the user equipment, it uses the PDCP protocol to carry the IP packet. Okay, that is where the PDCP will come into a picture. Okay, Packet Data Convergence Protocol, PDCP, right? So it is carrying the IP packet from ENB to the user equipment. That is one part of that is about the user plane. As far as the control plane is concerned, I said RRC is there, right? Radio resource connection. Then rest of the things means this control plane is used for carrying various control signals, okay, from the core network to the user equipment. So in that I said the two things. One is SDU and another one is PDU. So SDU means what? Service data units. Means it is the service given by the higher layer to the lower layer. Okay, that is say for example here from RLC to the MAC. Okay, so RLC will provide a services to the MAC layer through what? Through logical channels. So the packets there we call as SDUs, service data units. What is this PDU? That is packet data unit, right? So here the lower layer will provide services to the higher layer. That we call it as PDU, okay, packet data unit. Means the MAC layer can provide services to the RLC layer. That we call as a PDU, right? So we were discussing about what are the functions of MAC layer, RLC layer, what is the PDU formats of RLC, MAC layer, and I discussed about the PDCP functions and formats. Okay, so next topic is the RRC. So let me take up that RRC. Okay. Yeah. Yeah. I hope it is visible now. My slide is visible. Hello.
Yes, sir.
Yes. Yes, ma'am. Good. Good. Came. Okay. I will. Fine. I will go for this full this one. Yeah. I said let me talk about RRC, right? Radio resource connection protocol. So RRC layer takes care of RRC connection management and as well as the radio bearer control. Okay. And it also does the mobility functions. Okay. And user equipment measurement, reporting and control also. And in addition to that, it does broadcasting system information and pacing. Okay, so it takes care of all these things. Yeah. So RRC, right? I was telling RRC layer is what it comes under a control plane. It takes care of what? RRC connection management, radio bearer control, mobility functions, user equipment, measurement, reporting and control. In addition to that, it does the broadcasting system information and pacing. So RRC states, so it has two states. Okay, means LTE has two states. One is RRC idle state, and second one is RRC connected state. Okay, since it has only two states, it simplifies the RRC state machine handling and as well as the radio resource management, which controls the RRC state. Okay. So when the user equipment, okay, is in the RRC connected state, okay, when the user equipment is in the RRC connected state, so when RRC connection has been established, we say, okay, to say RRC connection is established, when do we say? When the user equipment is in the RRC connected state. And otherwise we say the user equipment is in the RRC idle state. Okay, so these are the two RRC states which are there in the LTE: RRC idle state and RRC connected state. So when do I say the user equipment is in the RRC idle state? When it is not connected, right? So when an RRC connection has been established, I say the user equipment is in the RRC connected state. Otherwise, I say the user equipment is in the RRC idle state. Right. So one is I said RRC idle state, another one I said RRC connected state. So from RRC idle to connection, right? It has to, if a user wants to make a phone call, it has to be connected from, it has to switch over from idle state to the connected state, right? So that is what is shown here. Connection establishment we call. Then this one we say connection release, right, to come to idle state, right? So what it does in RRC idle state means this RRC states, right? It is a user equipment controlled mobility, means it can do selection or reselection. Okay, it does paging, then it does the broadcast of system information, and it does unicast data transfer, right? Then network controlled mobility means handover, then paging. Okay, then broadcast of the system information. Just let me go further. Okay, let me take the first. What is that? RRC idle state. So the user equipment can receive the broadcast of the system information and paging information when it is in the idle state. So when do I say the user equipment is in the idle state? When it is not involved in any of the phone calls. Right? During that time, I say it is in the idle state. So during that time, it can receive the broadcast of system information and as well as the paging information. And there will be no signaling radio bearer established, so there is no RRC connection. Right? So mobility control is handled by the user equipment. It also performs neighboring cell measurements and cell selection or reselection. This one. So I usually used to say our mobile phone will be able to, means it will be monitoring continuously the 6 neighbor base stations signal strength. Okay, so depending upon which base station signal strength is more, it will switch to that base station. Okay, that is why I said it performs neighboring cell measurements for the cell selection or reselection when it is idle state. Okay. So as I said, the system information that contains what parameters like cell selection or reselection process, such as priorities of different frequencies, okay, which means which band to use and all. So user equipment is allocated an ID, okay, that will uniquely identifies the user equipment in the tracking area, right? So user equipment monitors the paging channel to detect the incoming calls. Our user equipment mobile phone always monitors the paging channel to detect the incoming calls. Okay, and it also specifies the paging discontinuous reception cycle also, that is DRS cycle. So that is in the idle state. So in idle state, it does all these things. Right. So in the RRC connected state, what happens? The UV has an RRC connection, right? And we say that E-neutron. E-neutron is what? RAN, what is E-neutron, right? It is able to transmit and receive data to or from the network, right? When it is in the connected state. It means user equipment is able to transmit and as well as receive data to from the network. So it monitors the control channels like PDCCH, that is what? Physical downlink control channel, right? Associated with the shared data channel to determine whether any data is scheduled for it or not. Okay? And it can also support means user equipment can also support channel quality information and the feedback information to the ENB. Okay. This is all done for assisting the data transmission. Okay, and it also does the network controls, mobility or handover of the user equipment. So user equipments will provide, as I said, the neighboring cell measurements information to the ENB. I said, no, 6 neighbor base stations, signal strength it will be monitoring. So that is all about when it is in idle state, what happens, when it is in connected state, what happens, RRC idle state and RRC connected state. So let us see what are the functions of RRC. So it does signaling radio bearers, SRBs. Okay, so what is SRB? How do we define the signaling radio bearers? Is defined as radio bearers that are used only for the transmission of the RRC and NAS messages. What is NAS messages? That is a non-access status messages. It is okay. Means it is there will be a direct flow of messages from user equipment to the core network. That is known as NAS messages. And see, there are 3 different SRBs. Like, as I said, the signaling radio bearers. No, I said what are these signaling radio bearers? The signaling radio bearers are the radio bearers that are used only for the transmission of what? RRC and NAS messages, right? So there are 3 different types of SRBs defined in the LTE. That is SRB0, then SRB1, SRB2. SRB0 is used for RRC messages using this common control channel. Okay. Then SRB1 is used for the RRC messages and NAS messages prior to the establishment of SRB2. All these will be using the dedicated control channel, that is DCCH. The previous one is using what? Common control channel, SRB0. Okay. Then SRB2 is used for NAS messages using this downlink control or dedicated control channel. Okay. So these are the 3 SRBs, signaling radio bearers. Oh, it is clear, I think. Okay. Among these 3, this SRB2 has the lower priority than SRB1 and is always configured with the E-Utron after security activation. Okay. Okay. So what are the main functions of the RRC protocol? So first one is, I can say, broadcast of system information. Okay. So as I said, the broadcast of system information, I said when I am saying system information, it is 2 large that will be divided into 2 informations. Right? One is a master information block, and second one is the what? System information block. We call that as SIB. Right? MIB and SIB. I think we have discussed many times about these things in the earlier classes. Right? What MIB contains, what SIB contains, and all. Right? So MIB, that is a master information block, will have what? Limited number of the most essential and the most frequently transmitted parameters that are needed to acquire other information from the cell. Okay, and it is transmitted on the broadcast channel, that is BCH. Okay, so SIBs. Okay, and even I think system information blocks. No, it has again the different types, SIB type 1 and other things. So in that SIB type 1 are carried in system information messages, that is SI messages. So SIB type 1 contains parameters needed to determine if the cell is suitable for cell selection, as well as information about the time domain scheduling of other SIBs. Okay, that is about SIB type 1. So SIB type 1 and all SI messages, okay, are transmitted on the downlink shared channel. So that is as far as the first thing is concerned. Okay, next function is of this RRC protocol is the RRC connection control. Okay, so the procedures related to this RRC connection control are establishment, modification, release of RRC connection, paging, okay, initial security activation, establishment of SRBs, radio bearer carrying user data, okay, radio configuration control, quality of service control, recovery from the radio link failure. Okay, these are all the procedures which are related to the RRC connection control. Okay, so right. The next, this is the third function done by RRC protocol. That is what? Measurement, configuration, and reporting. This measurement, configuration, reporting is done by this. It has establishment, modification, release of measurements, configuration, is a activation or deactivation of measurement gaps. Then it does the measurement reporting for intra-frequency, interfrequency, and inter-rat mobility. Okay, and in addition to that, other than these three, okay, broadly said three functions, right? Other than that, it also does transfer of dedicated NAS information and non-3GPP dedicated information. And it also does transfer of user equipment radio access capability information and support of self-configuration and self-optimization. Okay, so these are the functions carried out by the RRC protocol. Okay. Okay, I will come back to this mobility management. Okay, so till this, what I mean to cover RRC. So any questions to ask, you can ask. Now it is time for you people to ask questions. So many things are there, okay, on each. As I said, see, the main functions of the RRC protocol will be, say, three. One is broadcast of system information. Second one is RRC connection control. Third one is measurement, configuration, and reporting. Okay, and for each, it has so many things. Broadcast of system information has two things. One is we say master information block. Second one is system information block. Right, about RRC connection control, so many procedures are related to that, right? Like establishment, modification, release of an RRC connection, paging, initial security activation, establishment of SRBs, radio bearers carrying user data, radio configuration control, quality of service control, right? The recovery from the radio link failure. And as far as measurement, configuration, and reporting is concerned, these things: establishment, modification, release of measurements, configuration, and even measurement reporting for intra-frequency, interfrequency, and inter-rat mobility. So other than that, it also does two things. One is the transfer of dedicated NAS information and non-3GPP dedicated information. And it also does the transfer of user equipment radio access capability information and support of self-configuration and self-optimization. Okay, so this is all about RRC. So have any questions to ask, you can ask me. So let me start mobility management in the next class. So two more topics are left out in this module. Let me see how much I'll be able to cover. Let me cover. Any questions? So you can chart your USN in the chat box. I'm not finding anybody's USN in the chat box. Yes, all of you can chat your USN and your questions also. Or at least in few words, you can chat what you have understood along with your USN. At least name of the topics you can quote now. Instead of just writing your USN, just highlight the topics only. And anything to be discussed about your test, I said module 3 and module 4 is that you want me to include module 5 instead of module 4? Yes, people should respond. I feel module 5 is good and it is easy also compared to module 4. What do you all think?
Yes, sir. Only 3 and 5, sir.
Yeah, 3 and 5. That is what I feel, because module 5 content is less. Few topics. No, whatever I thought yesterday and today. And tomorrow, maybe one more class if I take, it will be over. Few topics and I will be able to score 20 marks, no doubt. So within that only they will ask. So, and it is interesting also, no? Because you are already studied CCN and other things. You are familiar with those layer protocols. Most of the things are common only, right? About MAC layer, RLC layer, maybe PDCP is new thing here. Then functionalities about ARQ, those things, right? Means easy to correlate, understand, and all. I feel. Yes, you should chat in chat box, or you can. If you want me to include, I will include module 4 because still module 4 some more topics are there. I covered 9.1 and then last topics I covered cell sets, random access, and power control. So let me include those topics, few topics from module 4, whatever I have taught, and module 5 full. I think that is better.
Yes, sir.
To prepare for exam, university exam. Only I left CQ and resource. This one in module 4. Yes, only Manjunath is telling. What about others? Please chat in chat box. Neha, Raghav, other students also. Yeah,
Sir, at 11 a.m. we don't have optics, sir. So you can schedule it. No?
ಗೊತ್ತಾಗ್ತಾ Yeah, Manjunath?
Sir, at 11 a.m. we have optic. We don't have optic class, sir. So you can schedule at 11 a.m. sir, if you are free.
Oh, 11 a.m. I can take. You don't have class. Okay, then it is better. I will take at 11 o'clock only.
Okay, sir.
Fine. What about this syllabus?
Yes, sir. 3 and 5 is fine, sir. Module 3 and 5.
Module 3 and 5. What about module 4? Some topics, like important topics, that is cell search, then random access procedure, power control. They're all important only. It will come for exam. Those 3 topics also you can study now. Uplink, downlink, hybrid ARQ, feedback procedure is there, right?
It will be more for us to study, sir.
It will become more.
Yes, sir.
But it will help for your university exam, man. Fine. But I think in module 3, what about module 3 is not much. You all decide, and is it possible to share in your that Google class? Shashank. All you can discuss. You tell me. As of now, I have posted as module 3 and 4. If you all feel to include a few topics of module 4, I can include.
Module 3 is big, sir. Module 3 have so many topics, sir.
That is what module 3 is, so depth also. Then what you wanted to do? 4 and 5? In 4, I have some more topics to cover. If you feel without understanding module 3, you can't understand module 4, man. That is also there. There is a link.
3 and 5 is enough, sir. I guess.
3 and 5 is enough, ಆಯ್ತು ಎಲ್ಲರೂ ಒಪಿನಿಯನ್ ಕಲೆಕ್ಟ್ ಮಾಡಿ ಹಾಕಿ
Okay, sir.
ಕ್ಲಾಸಲ್ಲಿ ಹಾಕಿ ಗೊತ್ತಾಗುತ್ತೆ. So as of now I said 3 and 4, but let us not have any confusion. Okay, do well because it should help for your university exam also. Yes, I understand it is more because I have also undergone making PPT, learning things. So much of depth is there. That is true. So then let me start at 11 o'clock. Today?
Okay, sir.
Okay then.
Okay.
Thank you.
Okay, sir.
Thank you.